Hi there, and welcome to Remote Learning Lesson number 20. Today's lesson is on multi-step division word problems. The LEQ for today's lesson is, how does my knowledge of division and decimal division help to solve real-world problems? Our objective for today is, I can solve multi-step division word problems. Here are some addition and subtraction key terms to support you throughout this lesson. Here are some multiplication and division key terms to support you throughout this lesson. Please refer back to these two slides to support you anytime you get stuck. Before we begin, let's review the strategy cubes. The C in cubes means circle the key numbers. The U in cubes means underline the question. The B is box in any math action words, and please refer to your charts whenever you get stuck. The E in cubes is evaluate. What steps should I take? This is where you actually think about what you want to do. And the S in cubes is solve and check. This is where you do all of your work and then check to make sure that your answer makes sense. Let's start with problem 1. Ava is saving for a new computer that costs $1,218. She has already saved half of the money. Ava earns $14 per hour. How many hours must Ava work to save the rest of the money? So we know some information that Ava's saving up to buy a computer. The total cost of that computer is $1,218, and we know that she saved half of her money. Ava also has a job, and every hour she works at her job, she makes $14. And the question is, how many hours does she have to work to save up the rest of that money? So let's start with C. Let's circle 1,218. That's how much money the computer costs. Let's circle $14. The $14 is how much she makes every hour she works. And let's go ahead and underline our question. It says, how many hours must Ava work to save the rest of the money? So we need to figure out how many hours she has to work. So before we have to do that, we have to figure out actually how much money is considered the rest of the money. So let's go ahead and let's box in all of our keywords. The first keyword is the word half. When you think of half, you think of a fraction, but it's also a keyword for division. Half means divide by 2. Per is a multiplication word. It means to multiply something. And it's probably going to say how many hours times the 14 till she gets a total. And the less is the rest. And we'll figure out the rest in just a little bit. Let's start by thinking about that half. Half means divide by 2, so we're going to start by dividing. We're going to take that 1,218 and we're going to divide it by 2 so we can see how much money she has yet to save. So make your garage, skip count by 2s because we know it's divide by 2, and go ahead and start dividing. 2 cannot go into 1, but it can go into 12. It goes into 12 6 times, and 6 times 2 is 12. Subtract and you get 0. Bring down that 1. 2 cannot go into 1, so 0 up and down, and you subtract 1 and 0, and you get 1. Bring down that 8. 2 goes into 18 9 times. 9 times 2 is 18. Subtract, and you get 0. So right now, we know that Ava has saved $609. We also know that Ava needs to pay $609 more to get that computer. So that's what we know for now. We know that every time Ava goes to work, she makes $14. So we need to know how many hours she's going to work to save up that $609. So that's another division problem. Even though per means multiplication, it's 14 times the number of hours to equal that 609. Since 14 and the number of hours are our factors and we don't know them both, then we have to do the opposite of multiplication, which is division. So go ahead and set up your garage. On the outside is the 14, and on the inside is the 609. And let's go ahead and start skip counting by tens. And the reason why I skip counted by tens is because when you round 14 to its leading digit, you get 10, and 10 is a supporter. So let's go ahead and start our division. 14 can't go into 6, 0 up. But 14 can't go into 60. 10 goes into 60 6 times, but 14 is larger, so I'm going to actually try 5 times. Right down below, I'm going to do 14 times 5, and unfortunately, I get 70, and 70 is too high. So I'm going to try 14 times 4. 14 times 4 is 56, which is a just right number, because remember, you need to have a number that can actually subtract from the number above it. So we're going to put the 4 up on top and the 56 down below and subtract using subtraction rules, 60 minus 56. And I get 4. Bring down that 9 next to the 4, now we have 49. So now if we look over to the left-hand side, 10 goes into 49 4 times. But since 14 is larger than 10, let's try 3 times. And since we've already done the 4 times down below, we know that 4 is too high. So we're going to try 14 times 3. When we multiply 14 and 3, we get 42, and that's the best answer. So we're going to put our 3 up on top and our 42 down below, and we're going to subtract the 2, and we get 7. Now remember, when you're dealing with decimals, you're not going to have a remainder. So we're going to add a 0 into that dividend. We're going to bring that decimal up, and we're going to drop that decimal down, and now we have 70. So if you look at some of the work that you've already done, you already know that 14 goes into 70 evenly. 14 goes into 70 5 times. 5 up, 70 down, subtract, and you get 0. So Ava's going to need to work 43.5 hours to save up that extra $609. So she actually has to work 43 and a half hours. She must work 43.5 hours before getting her computer. Problem number 2. Michael has a collection of 1,404 sports cards. He hopes to sell the collection in packs of 36 and make $633.75 when all the packs are sold. If each pack is priced the same, how much should Michael charge per pack? So we know that Michael has sports cards. He actually has 1,404 sports cards, and he wants to put them in bundles of 36. So we already know that he's got a big number, which is our total, and he's going to actually break it down into smaller sections. That's a division problem. And then after he figures out how many sets of cards he has, he wants to actually make a total of $633.75. Again, that's another total, which is going to create another division problem. So we have 2 division problems that we're dealing with. Here are some key words. Well, first, let's do our question. How much should Michael charge per pack? One of the key words that sticks out to me is the word same. Same is a key word for division. The word each is another key word, and that's a good supporter for that division. So let's go ahead and start to divide. Let's put our 1,404 in the garage and divide that by the 36. Again, we're going to have some supporters, so we're going to round that 36 to its leading digit, which is 4. So we're going to skip count by 40s off to the side. Let's divide. 36 cannot go into 1, and it actually can't go into 14, but it does go into 140. So when I look off to the list, I see 140 and 160. So it's 120 and 160. I know that it's somewhere in between there. I'm going to try the 120. So off to the side, I'm going to multiply 36 times 3. And 36 times 3 is 108. And then I start to think, well, if I add 36 to that 108, it's going to give me more than 140. So 3 is going to be my best choice. And 3 times 36 is 108. I'm going to subtract using my regroup rules, and I'm going to get 32. And 32 is a good number to subtract with because it's smaller than that divisor. So let's go ahead and bring down that 4. 36 goes into 324. When I look off to the side, I see 320. So I'm going to try to do 36 times 8, and I get 288. Maybe it's good. Maybe I should try 36 times 9. And 36 times 9 is 324, and that's my exact number, and that's what I want. So I put my 9 up and my 324 down below, and I subtract, and I get 0. So right now, I know that Michael has made 39 packs of cards. With those 39 packs of cards, he wants to make $633.75 total. So we need to know how much one pack of cards is going to be. So we're going to go ahead and we're going to divide that. Put our 633.75 in the garage and divide it by that 39. And then we're going to just bring over that 40 again because 39 rounds to 40. And let's start our division. 33 cannot go into 6, but it can go into 63. I think the best bet for me is only one time because 2 times is 80 or close to it. So that'll be too high. So subtract using regroup and you get 24. That's a good answer because it is below 39, so I can keep on going. Bring down your 3, and now you're looking for a number close to 243. So let's try this one. 39 times 6. 39 times 6 is 234. That's a good one. Let's put it right underneath and subtract, and I get 9. 243 minus 234 is 9. Let's move on. Bring down that 7. How many 39s do you think go into 97? It's not 1, maybe it's 2. 39 times 2 is 78. Good one. Put the 78 underneath, use your subtraction rules, and you get 19. Bring down that 5 and figure out how many 39s go into 195. 39 goes into 195, looks like 5 times. And 39 times 5 is 195. So Michael sells each pack of his sports cards for $16.25. Wow! Problem number 3. Kenny is ordering uniforms for the tennis club. He is ordering shirts for 20 players at a total cost of $658. Additionally, he is ordering visors for each player at a total cost of $368. How much will each player pay for the shirt and the visor? So let's think about this. Kenny's ordering uniforms, and each player is going to get a shirt and a visor. And a visor is just kind of like a baseball cap, but it's got an opening on the top part. So they're each getting a shirt and they're each getting a visor. But the problem is that they don't tell you what each player is going to pay for each one of them. They actually tell you how much it's going to cost for all of the players. There's 20 players, and the total cost of the shirts is $658. And the total cost of the visor is $368. So we know that we're going to have to figure out how many is it for one. So when you're thinking about each, you know that you're going to have to do some division because we want to know how much will each player pay. So we know the word total is a key word for multiplication, but it's also a supporter when they actually give you the total, because then you know that it's actually not multiplication, it's actually division. And there's that word each, and each means for one. And right now we only know about 20. And then there's another total because the hats, the visors are total $368. So again, we know what the big total is, but we want to know how much one is. So that's another division problem. And then of course, there's that word each, and each means you want one. And finally, that key word and, because they want to know how much it is for one shirt and a visor. And that word and means to add. So we have 3 steps here. We're going to figure out how much it costs to do the shirt for one person, how much it is for the visor for one person, and then how much it is for the shirt and the visor together. So let's go ahead and set this up. Let's start with our division of the shirt. We're going to make our garage. We're going to put our 20 and our 658 in the correct spots. And we're going to skip count by our 20s off to the side. And this is a good one because what we skip count by is actually what we're going to be using. 20 does not go into 6, but it does go into 65. It goes into it 3 times. So 3 times 20 is 60. Subtracting, you get 5. Bring down that 8. 20 does go into 58 4 times. And 4 times 20 is 40. When you subtract, you get 18. We're still going to be working with decimals because we need to make sure that we don't have remainders. So when you have that decimal, the decimal's got to go up and it's got to go, and the zero's got to go down. Now 20 goes into 180. It goes into 180 9 times. And 9 times 20 is 180, and you subtract and you get 0. So what we do know is that the shirts cost $32.90. And the reason why I don't just say 32 and 9 is because when you're dealing with money, you need two places. So you know that you can fill an extra space with a zero. So it's going to say $32.90. Let's do the visor. 20 on the outside, $368 on the inside, and 20 does not go into 3, but it does go into 36, and it goes into 36 once. When you subtract the 2, you get 16. Bring down that 8, and 20 goes into 168 8 times, and 8 times 20 is 160. You subtract the 2, and you get 8. Bring that decimal, bring it up, bring the 0 down, and now you have 80. And 20 goes into 80 4 times. So to get a visor, it costs $18.40. So the shirt costs $32.90, and the visor costs $18.40. So I'm going to take my $32.90 and my $18.40, and I'm going to add those two together. And I'm going to get a grand total of $51.30. So each player will pay $51.30 for their shirt and visor. Problem number 4. Adam has 16.45 kilograms of flour, and he uses 6.4 kilograms to make hot cross buns. The remaining flour is exactly enough to make 15 batches of scones. How much flour in kilograms will be in each batch of scones? So let's break this problem down. Adam, he's a baker, and he's got flour. He's actually got a total of 16.45 kilograms of flour. And then he uses some. When you use some, you're actually taking it away. And he uses that 6.4 kilograms to make delicious hot cross buns. And then with the remaining flour, which means that's what he has left over after you subtracted some, he makes 15 batches of scones. Scones are some treat that they have out in England where it's kind of like a muffin top, but kind of hard. It's like a cookie. So he's making 15 batches of scones, but we really want to know how much flour is in each kilogram, in the kilograms will be in each batch of scones. So we don't want to know 15 batches, we actually want to know one batch. So let's go ahead and think about this again. So if he's using 16.45 and he gets rid of 6.4, we're subtracting what that uses. The remaining is what's left after you subtract those two numbers. And then he's using exactly enough, exactly is our keyword for division, to make 15 batches of scones. And how much flour will be in each batch? Each is our keyword to help support that division. Right now, we know we've got two problems here. We got to subtract, and then we've got to divide. So let's go ahead and set up our subtraction problem. 16.45 minus 6.4, and I just added a 0 at the end to make that 5 subtract correctly. So go ahead and subtract them, and you get 10.05. So that's how much flour he has left. So we're going to divide that by the 15 batches of scones he's going to make. So put your 15 on the outside and your 10.05 on the inside, and then you're going to round to your leading digit so that the 15 is going to round to 20, and that's a very interesting number because 15 is actually 5 digits smaller than 20. So keep that in mind when you're trying to find the best number to multiply with. So skip count by your 20s, and let's go ahead and start to divide. 15 can't go into 1, and it can't go into 10, but it can go into 100. If you look off to the side, 20 goes into 100 exactly 5 times. So why don't we actually not do that and go 6 times? That way we can see if it's closer. Which 15 times 6 is 90. So we're going to pick that. We're going to subtract 100 minus 90, and we're going to get 10. Bring down that 5. And if you didn't forget, don't forget to bring that decimal up. Now we have 105. Now we know that 15 times 6 gave you 90, so 15 times something is going to give you higher. So let's try 15 times 7. And 15 times 7 gives us exactly 105. So 7 times 15, let's put it underneath and subtract, and we get 0. So it takes Adam to make one batch of scones, 0.67 kilograms of flour. So each batch of scones will have 0.67 7 kilograms of flour. Now it's your turn to complete your problem set and application problem independently. Please complete both sides, both of them, and send me a picture. Text it to me, email it to me, send it to the Remind app, Google Classroom. I don't care how it gets here. I just need to see it for you to get credit for this lesson. Can't wait to see your work and can't wait to see you. Bye, boys.